Hello everyone. Hope you are doing well. We are Team Loud and Cloud from NIT Raulkela. The problem we are working on is improving the targeted vaccine delivery as soon as the massive vaccination program starts in our country, India. So let us understand what is the current scenario. In the current scenario, the world is heading towards a massive vaccination program, and it will be bad to expect that all the vaccines for the entire country will be available in initial stages. So there is a necessity of making strategic decisions and wise analysis on what are the conditions of COVID-19 in India at current time, so that the vaccines can be delivered to at the correct locations with locations of higher risk and priority, and to the correct people. So our solution is based on that. We provide an effective model of determining what will be the risk of every district in India in upcoming 15 days, which will help us to determine the best possible priority of vaccines and the requirement in future uh, on basis of the model. So I would like Hers to explain the first component of our website risk assessment. Over to you.
Hi everyone. My name is Harsh. I'll be explaining the risk assessment component which we have built. So as you can see, the risk assessment component here, it is a risk-based heat map of the entire country based on the different constituencies. And what this component does is that it actually tells us the value of the risk that is associated with each district, and the risk value is calculated based on the active cases and the total number of deaths that have occurred in that constituency. So we can see that the key here provided tells us that the districts with the lowest risk are green in color, and it moves on to red, which shows that districts with red color are at the highest risk of having new active cases. When we hover over a constituency, we find that we have provided here the population of the constituency, and we have provided the new total number of active cases that would be in that constituency after 15 days, and the total number of new active cases that will be added to the current active cases. Also, we have provided the value of the risk. As we mentioned earlier, it was based on the values of the active cases and total number of deaths. So what this component will do is that it will provide the delivery agencies to decide whether which constituency they have to deliver the vaccines first. It can be decided based on the population and also based on the value of the risk. If we hover over a certain constituency, we can find the risk and then decide our delivery methods based on the values given here. So the next component that we have built is filter by parameters. So Roshan, over to you to explain the filter the parameters component.
Yeah. So the filter by parameters component basically provides us the districts based on some parameters which are filtered. So for an organization which is going to deliver vaccines, risk is important, but not the only important thing. For example, somebody who wants to know which districts have high population, to understand the outspread of the virus if number of cases increase there, they need to filter the districts basis on certain parameters. For example, having some greater number of spike in active cases. So this tab is used to monitor all of that. So on clicking on risk score, as you can see in the tab, we have three options which gives us the default, which is a normal risk, and we have high risk cases and low risk cases. On clicking on high risk, we will be able to see that this districts marked in red have higher risk, uh, as risk of getting a risk of having COVID cases in future, and this will tell us that these are in high priority regions in future. Next, we can go for active cases, and we can see, let's see active cases low, so that we can understand that these are not like most priority districts of most priority in our case. And when we go for population as high, then we will be able to understand that the high population regions will give us the areas where if the active cases rise, then the outbreak or the spread of the virus will be more. So this kind of statistics helps the organization to determine where to deliver the vaccines and to which particular cluster of districts. And this is why this tab is pretty useful for and a very cool feature for this project. Next, I would like to like hers to explain the general statistics tab.
Yeah. So the general statistics is a interface that we have built which tells the user the active, confirmed, and recovered cases for each constituency at the current moment, which we have the data we have fetched from uh, official websites. So what we can see here is if we click on active, we can find that active cases currently in that constituency. So we can see that the Farrukhabad we have active cases 112 at the current time. We can also go to the confirmed cases and see the total number of confirmed cases that have happened in that constituency since the pandemic has started. And we can also go to the recovered to find the total number of people who have recovered from the disease. And so if we go to Jodhpur, we can see that the recovered cases are pretty high, 41,000. So we can use this interface to determine which constituencies are at high risk because different agencies might have different ways of determining where they want to deliver first. So they might do it based on the active cases, they might also do it based on the confirmed cases, and recovered cases can also be quite helpful in that sense. So yeah, this was the general statistics component that we have built. And the components that we built, feel that these components might be pretty helpful in the future when the vaccination and the delivery of vaccinations actually start. So this was our project. Hope you enjoyed it. Thanks.
So guys, if you are interested to know what will be the vaccine requirement for your district in future, you can check out the web app which is deployed at projectmanna.herokuapp.com. So thank you.
Hello everyone, I'm Abel from the team and I'm here to explain the vaccine requirement section of our project. This module can help us prioritize which areas in the entire nation should be vaccinated first. Risk is a factor which is not a direct measure of the quantity of the vaccines required. We are using the population data as well to find the vaccine requirements for the state. So if I take the state example as Bihar and I look at the high vaccine risk region. So give it a few seconds and we see that the count of people required is shown over here. This count is shown right now over here, but when we have a vaccine ready, we can set up a multiplier which will show the amount of revenue that is required to actually vaccinate the people from Bihar. So this was a direct impact that can be utilized to know the revenue generation needed to actually vaccinate a region which has a given amount of risk, and hence the spread of COVID-19 can be subsidized given the amount of funds and vaccine. Thank you.
So, hi guys, this is Shayan Day. So, I'll be explaining the backend part of our code, which comprises of a model that takes in the district-wise COVID statistics of India, and it kind of estimates the urgency of vaccination in that district. So you can see here is the flowchart of our model, how we made it. The model was initially a basic SIR model, which is a kind of a district spread, which models the spread of a particular disease. And we added more compartments to it, and we got an enhanced SIR model. Then that model was further improved by considering the vaccination scenario, because SIR model is not made for vaccination cases, but we had to also consider that vaccinated people cannot infect or cannot get the disease of COVID, and that's why we enhanced the SIR model further to coping with the vaccination scenario. And then we got a full-fledged SIR model. So this SIR model takes in the time series data, district-wise time series data of COVID-19 in India, and as well for the population, it takes in the census data of India. And once so we initialize the model for each of the districts, and we get a model for each of them, and for each of the model we fit the data of that district. Once we fit the data, we predict the new cases possible in upcoming 15 days for that district. Say that is district X, right? Now we take that value. That value is basically integer. It can be 80, 90 or whatever. Now we normalize that value between 0 to 1, and that is we are um, denoting as risk of COVID in that district. Okay, that kind of resembles the risk of COVID in that area. Further, we are multiplying that risk with the number of susceptibles. That means those who haven't yet got COVID but are also not vaccinated, right? They should not be vaccinated. So we are multiplying them, and we are getting a vaccination urgency for district X. Now see, this number of susceptible is the absolute number of vaccines we need for that district. But if you don't have sufficient number of vaccines available with you, then you have to give some kind of priority for different districts, right? And that's where this particular value, that is the vaccination urgency, comes in place. Now this small picture gives the validation of our model, which fits in the COVID data for a particular district, that is Anantapur in Andhra Pradesh, and the fit is quite good. You see the yellow mark is the fitting part, and the real data is the blue one. So as the fitting is quite good, we can say our estimation is quite good. So thank you for this. The front end presentation will come up soon after this. Thank you.